The most popular architectural style today is the microservices architecture. Beginners to microservices are overwhelmed with some of the technology which is involved in building microservices. Docker, Kubernetes, Spring Cloud, and a lot of other things. I have the experience of helping more than 100,000 learners start their journey with microservices. In this video, Amit and I will discuss the fundamentals of microservices and help a beginner to microservices understand how they can start their journey to microservices. Docker, Kubernetes, Cloud, Spring Cloud, these all might seem really difficult at the start. But if you understand where they fit in and the kind of value they bring in, they become really easy to learn. So let's make microservices easy to learn and let's get started. Amit, I'm delighted to have you in here with me.
Thank you very much, Ranga, for the introduction. Pleasure is all mine. It's always great to have sessions with you and share our knowledge with the learners. So today, as you said, we'll be discussing about microservices. But for me, like I'm starting new into my microservices learning journey with a blank slate, practically. And I come from a very kind of old-fashioned world where it's like JSP servlets, right? It's just client server or max to max. My the thing would be MVC architecture. That's the maximum I would go ahead with. Now my organization wants to use microservices and go like transform the product to a microservice world. So where should I start like learning about microservice? Like help me understand what is microservices.
Yeah, I think we like to we like to create a lot of technical jargon, right? So if you look at the entire journey, right? So if you look at the last few years, I would say the key milestones were web application, and slowly we migrated to web services, and there were a couple of prominent styles of web services, SOAP and REST, and then we evolved to microservices, right? So that's kind of at a high level the important components of this journey. Earlier, we just built a few web applications, JSP servlets, or things like that. Quickly build a web application and put it out there. But we saw that there were a lot of devices which are coming into picture. So we had a mobile device, we had like a lot of devices coming in, and it's no longer like we wanted to start building applications which can talk with each other, right? So it's no
Right.
longer silos. We wanted applications to talk to each other, and that's where the importance of web services came into picture, right? So once you have a web service, this web service can be called from a Python application or Java application or a mobile application anywhere, right? So that's where we started talking about web services, where we take some kind of business logic and put it away, and somebody can make use of it by calling it. Right? That's what we call web services, right? And when we
Yes.
started with web services, we had a lot of formality around these web services. We had, okay, you need to say what should be the request format, what should be the response format. They should all be very, very formally defined, and that's what we call SOAP services. We had a BizDel, a lot of complexity, and yeah, we would be talking about service buses and a lot of things around there. So
We have XSDs at that time. We have to specify to the XSD specifications. Oh my god.
exactly. So that's where we started, right? So we have, that's what we call as SOAP web services, simple object access protocol. And then from there, we slowly said, okay, this complexity is too much. This is getting really like if I have to create a simple web service, it's becoming really complex. How can we make use of the facilities which are provided by HTTP? HTTP is what all our browsers makes use of, and that's where okay, we thought okay, if I'm able to render a web page in such a easy manner, why do I need all this complexity in SOAP? And that's where that's where Roy Fielding came up with this concept of REST, right? And it made it they made like they removed some of the formalities which are associated with building a web service, and from then on REST APIs became popular, right? So you would probably most of these REST APIs have a JSON request, JSON response, probably not such a standard request response kind of structure. So more flexible, making use of all the capabilities that HTTP provides, like the request methods, get, put, post, and that kind of stuff. So yeah, it became a little bit less formal. And as we went further, we saw that there are like building one monolith REST API is not the way to go. It is very, very important to break them down into small chunks. And that's where I think the microservices architecture comes into picture, right? So when we talk about microservices architecture, I would think the most important parts of a microservices architecture for me are the REST, the fact that we are making use of REST, and like when we are breaking out things, we need to choose how we break down things, right? It should not be a random breaking down just to make things small. So you would want to have well chosen independent deployable units. So basically, if I have like a set of microservices, then each of these microservices should be independently deployable. I would want to be able to deploy microservice one without affecting all the other ones. And the other important thing is cloud enabled, right? So you'd want to be able to increase the number of instances of microservice one without affecting the other instances. The load on these microservices can be different. So you'd want to be able to scale up, scale down each of these independently. So yeah, if you look at the entire evolution, we came out to REST, and after REST, the focus became on, okay, how can I deploy things faster? How can I make changes to applications faster? And that's where it became important to create smaller units and like identifying what should be in a smaller unit and making sure that they are independently deployable, making sure that they are independently scalable. I think that's some of the important aspects around microservices.
Right, right. That's the very important thing that you said, that they are identified independently kind of deployable and scalable. Hence, I think now that kind of leads my next question. So, what are the advantages? So these are the two advantages. Anything else that you see as a big advantage of why organization moves towards a microservice-based architecture?
Yeah, I think when we talk about microservices, uh, like uh, as we started going through the entire journey, right? So in software development, uh, after a little while, we saw that uh, some of the times having a monolith architecture becomes a big constraint. Because let's say I have a big monolith application and I would want to try a new framework or I would want to try a new language. It becomes really, really difficult to bring it into the existing system because you don't want a part of the system to be using something and another part of the same system using something else. So that's where I feel microservices architecture brings you a lot of flexibility, right? So let's say I have a microservice 3, which I'm going to build right now. I can start trying out a new technology, right? I can say, okay, this is something which might actually suit us. We can actually probably go and try a new framework, or even with respect to processes, right? So if you have a monolith, there are fixed processes. You cannot change the processes which are already associated with existing app, and that's where you can actually try probably building a new microservice in a new process, probably like at that particular time when the evolution of microservices was happening, like one of the that was the same time when agile was coming into picture. So a lot of these monolith applications were typically built with respect in a kind of a waterfall model. And if I wanted to try a agile model of development, like one of the quick wins was just to pick up an microservice. Probably if I have a microservice architecture, a specific microservice, I can take a different approach and see if it works for the team. So that's, I think, one of the biggest advantages that I saw with the microservices architecture, right? So it's the flexibility in terms of adapting to new technology and process adaptation, right? And also, like if you look at the dynamic scaling aspect, we already talked about it
Yeah.
earlier, right? So we would be able to scale independently. It's not like I have a monolith and like I have to scale the entire monolith. These might have dependencies, so scaling all of them might be difficult. But if I have individual microservices, I can scale individual microservices. And
Right.
also with respect to releasing new software, right? So if I have one monolith, it's like to release that, we have a 3-month cycle or a 6-month cycle. So new changes and innovations become really, really difficult. But if I'm having a microservice architecture, I can have separate release cycle for each of these microservices, and thereby like the innovation becomes faster, and I can also release much more often. Right? Today we talk about a lot of these popular enterprise companies like Google, Facebook, like Netflix, for example. Right? All these make maybe thousands of releases every day. Right? So all that is now possible just because everything is broken down into small chunks and they are using some kind of microservices architecture.
Right, right. So basically, what we say is, if we can like go to this diagram where you say in the legacy world, right? So in the legacy world, if there are, you say microservice one, two, three, four, five, they won't be kind of broken down. They would be like all stuck together as one piece of software stack, right? And
Right.
then any changes, for example, if you want to do in the area of say microservice 4, you actually there wasn't any kind of dividing line between these five, and it's like one entire piece of monolith software that you have to build and deploy. Hence the cycle was pretty long, like 3 months in some cases, or maybe more.
Yeah.
But with the microservices architecture, we actually kind of get an opportunity to kind of sit with the architect and re-architect the platform, and have an opportunity to break one big monolith application into small manageable microservices. So our change in, for example, microservice 4 can be independently done and deployed, and then kind of joined together into entire software stack. Uh, right, is a fair statement to put.
Absolutely. I mean, the breaking up a monolith into microservices is not an easy challenge, right? So
Right.
that's a very, very, very tough thing to do.
Yeah.
But creating a new microservice might not be as challenging. So yeah. So I think that's exactly, you summarized exactly the reasons why we would go for a microservices architecture.
Awesome. Awesome. So then, as you said, it's not easy. So what are the challenges then with respect to building a microservices based kind of software or architecture?
Yeah. So if you actually like, let's probably not worry about the migration aspects right now because that might
Yes.
be too overwhelming for a beginner. Let's say you
Correct.
are trying to bring in a new microservices architecture. I mean, you are building
From
a few
scratch.
new
Within the,
microservices.
yeah.
Then probably I think the first challenge that is very, very difficult to uh, like get right at the first go itself is deciding the boundaries of these microservices, right? One of the, like, if you look at architecture is about deciding boundaries. I have multiple components, and what is the boundary of each component? What should it allow? It should what should be it allowed to do, right? So deciding that is the most difficult process, and I think figuring that out is something which is not a one-time activity, but it's a continuous activity. So as you learn more about the business, as you learn more about the problem you solve, the way you decide the boundaries of your microservices keeps changing. So this is where I think concepts like domain driven design are really, really useful. A beginner to microservice might not really need to worry about it, but a beginner to microservice needs to understand that deciding the boundary of the microservice, what functionality should be in a microservice, that's a challenge, right? The second, like the rest of the things are more related to the challenges with breaking down a one big monolith into multiple ones, right? Instead of now having one deployable unit, I have multiple deployable units. And if you look at earlier, maybe I have a dev configuration, a QA configuration, a staging configuration. I just have one set of configuration for each environment. It becomes easy to manage. But now, once I break it down, each of these microservices have individual configuration for each of the environment. Which database, like each of these microservices might have an individual database to talk to. Each of these microservices might have its own set of services it needs to talk to. So configuration management becomes much more complex because now I have to have configuration management for each of these microservices individually, and that's a challenge. Another challenge we already talked about, right? So dynamic scale up and scale down. We talked about the fact that you would be able to increase the number of instances of a microservice up and down based on the load on it. But implementing it technically, I mean, putting the tools and frameworks in place to be able to achieve that functionality is a complexity. That's a challenge. And also, as we add more and more microservices into the picture, if there's a problem, you need to find out where the problem is. It's not so easy, right? If there's a problem, you have to figure out whether the problem is with microservice 1, 2, or 3, right? You don't know, and that's where you need to actually bring a lot of visibility into picture, right? So you want to be able to have tracing. Like if there's a performance problem, you want to be able to find out where the problem is, where the request is spending a lot of time in. That's where you have centralized kind of tracing, right? Distributed tracing. And then you also want centralized logging. When there's a problem, you want to be able to trace what's happening across microservices. That's where you have something like centralized logging coming into picture. And another big problem with the microservices architecture is, let's say this microservice 5, all the microservices are depending on this microservice 5. If microservice 5 fails, then entire application collapses, right? So
Yeah.
you'd start having a lot of things like that where your application kind of becomes a pack of cards. So failure, microservice failing is no longer an option, or you need to have workarounds. What if a microservice 5 fails? How can I come back with a proper response, or kind of can I offer an alternative? If microservice 5 is down, can I kind of do something and ensure that the upstream things are not really impacted because of that? And
Basically taking
the
care of
other challenge,
events, you mean to say?
is, apologies, Amit, can you repeat that?
What I'm saying is basically we need to take care of fault tolerance, developing
Absolutely.
infrastructure.
Exactly. Fault tolerance becomes really, really important. And like also the other factor is zero downtime deployments, right? When I'm making one release every 3 months, 2 months, I'm okay with a little bit of downtime when I'm releasing a new version. But once we would want to like once we go to microservice architectures and you are making hundreds of releases per day, you don't want downtime when you do a new deployment, right? So these are typically some of the technical challenges when it comes to a microservice kind of an architecture, Amit.
Right, right. So now what tools? Now these are all the challenges we have. Now what tools do we have at our disposal basically to overcome this challenges and build world-class microservices which addresses these challenges?
Yeah. So I think when we talk about the solutions which are popular in the microservices world, right? So let's first start with how you build a microservice, right? Microservices can be built in any language. There is no language constraint as such. You can probably a microservice can be built in Java. Uh, it can be built in Node. It can be built in maybe something like Python or Go
Isha?
these days. Yeah, C sharp, Go. So it's language neutral, right? So what we are focusing on here are specific solutions. Like if you look at Spring Cloud is something which is specific to Java, right? But
That's
there are also alternatives, right? Docker, Kubernetes. These are more the language neutral, right? So you can you can go with Docker and Kubernetes when you have like more like a Python or a Node, or you have a combination of these technologies involved, right? So let's first start with discussing about probably the Java based things, and then we will look at how you do a language neutral kind of things, right? So in Java world, I would say the most popular like framework to build microservices today is Spring Boot, right? Spring Boot was the first version of Spring Boot was released in 2016, and I think like somewhere 2015 2016 kind of time frame. And from then on, like it made it simple to get started with building microservices. So the basic features of how you build a REST API, that's where Spring Boot comes into picture. Similar frameworks are available for Python, Node that enable you to build a REST API. Once you have a REST API properly built, that's when you would want to bring in all the microservices related features, right? So earlier we were talking about centralized configuration management, and you wanted like once I have multiple microservices, I don't want to hard code the URL of one microservice and another microservice. That's where something called service discovery comes into picture. Once I have multiple instances of microservices, I would want to be able to distribute load between them, right? And also we talked about visibility and monitoring being very, very important. So, like on the Java Spring Boot world, Spring Cloud provides a number of solutions related to the technology aspects related to microservices, right? If you want to actually, let's say, have centralized configuration management, you can make use of Spring Cloud Config Server. If you want service registry, if you want something like a naming server, you can go with Eureka. If you want load distribution, if you want client-side load distribution, you can go with something like Spring Cloud Load Balancer. If you want visibility and monitoring, distributed tracing, like you can go with Zipkin, right? Also, there are a lot of common features which are present with all these microservices, like authentication, for example, or
yeah,
centralized logging, all those kind of things. That's where an API gateway comes into picture. Zool was the earlier one, and right now the recommended API gateway with Spring Cloud is Spring Cloud Gateway. And also, we want, as we discussed earlier, fault tolerance is very, very important, right? So that's where things like resilience for J come into picture. So Spring Cloud is just an umbrella of these things, right? So it's like you have all these solutions which are coming under a single umbrella, Spring Cloud, which are
yeah,
focused on making, providing all the technology that you typically need to build microservices. So that's where we started. Like if you go 3-4 years back, probably Spring Cloud was one of the most popular options when you are going for a microservices architecture. This is what even Netflix started with, right? So Netflix was kind of Java based, and they also started with something of this kind, not exactly Spring Cloud. Actually, some of the elements that Netflix made use of, like Hystrix, Zool, Ribbon, these are all things which came from the experiences in Netflix, and Netflix open sourced them, and they became part of the Spring Cloud umbrella.
oh,
So
great.
yeah, this is how we started a few years back. And as we went forward, we saw that, okay, it's not just Java applications, it's not just Java microservices. We would want to be able to have more language neutrality. Microservices can be built in many more languages than just Java, and that's where we started, uh, yeah, moving towards more kind of the language neutral solutions, right? So we started what happened as we started building more and more microservices in other languages is that operations for these become complex, right? If I'm actually, let's say, building microservice 1 in Java, microservice 2 in, let's say, Python, uh, the way operations team needs to deploy a Java application might be different from a Python application, right?
Correct.
So that's where, like, if I have different languages, then I would need operations team which is skilled in those specific, in deploying languages which are related to those specific things. Not just deployment, but also monitoring those applications. If there's no consistency between them, it becomes really, really challenging. I think that's the kind of world where the containers came into picture, right? When Docker came in, like, what it enabled us to do was, we can take a microservice, we can build a Docker image, irrespective of what language the microservice is built in. The final Docker image, the way you deploy it would be the same, right? So once I have a Docker image, it contains everything that your microservice needs. It probably contains the code for your microservice or the deployable unit for your microservice. It contains the runtime that your microservice needs. It can be Java, Python, Node, whatever. And then once you have this Docker image, you can put it in your data center. You can run it even in a cloud. Like a lot of these like popular cloud platforms also offer opportunities, like different ways to run your Docker images. So it became easy for us to run them anywhere. So it became like, okay, you build once and you can run it almost anywhere. So that's where I felt Docker played a very, very important role. It is language neutral. You can deploy it anywhere, and that's where Docker like came into picture.
Yeah, and I think the most important thing is it helped to reduce the kind of number of issues where the developer would say, well, it worked in my machine and it's not working in QA machine environment, right? So it kind of helped to reduce those the biggest advantage.
Absolutely. Absolutely. I think that's one of the like biggest contributions of Docker, I would say. It runs
Yes.
only on my machine. Those problems probably are not as frequent now
Once
because
Docker came, I would say the dev and QA lived harmoniously ever after.
yeah, and also it gives power to QA, right? Now, once I have a Docker image, a QA guy, I mean, even person from a software assurance team can quickly run that image. I mean, run that application and see what's happening, right? It was not so easy earlier. If you have a lot of dependencies to set up, probably a software assurance team member does not have the technical knowledge to be able to set all that up. But now you have Docker, probably you can have something like Docker Compose to set up all the dependencies and quickly
Yes.
get up and running with a small microservice, even in your local environment, even if you don't have a lot of technical knowledge.
Yes, yes, absolutely. Plus the operations team, right? It was so much kind of a blessing in disguise for the operations team, I would say, where they don't have to like run around the developers, like to give them the right set of config environments for deploying in production, or if it's a Linux, or if it's a Windows, those specific environment configurations.
Exactly. I think once the image is out there, I don't really need to have a document. Earlier, like for example, I like when like 5 years back, I had to write down a document saying, okay, first do this, then do this, then do
Yes,
this, and those are the instructions which operations team would manually follow when they deploy something to production.
yes,
And today with Docker, I mean, if you build a right Docker image which contains everything, you don't really need to pass that instructions on to the operations team, irrespective of what the Docker image has. The operations team would run it the same way.
absolutely. Yes,
Yeah, and that's what I think. Like that's where we slowly like and like Docker kind of simplified uh, how you manage a single application, a single microservice, and we also needed all the other features, right? We wanted features like service discovery, we wanted features like load distribution,
yep,
we wanted to be able to implement common features across microservices, and
yes,
that's where I think container orchestration came into picture, right? So container orchestration became really, really popular because it's not sufficient to have one container. You'd want to have multiple instances of each microservice and a number of microservices, and that's where like container orchestration solutions started becoming popular, we went towards more Docker Swarm initially, but very soon in the last couple of years, I would say Kubernetes has now become the de facto container orchestration solution. So it provides a lot of these features like centralized config management, location transparency, load distribution, something similar to an API gateway. Istio is one of the popular options when it comes to Kubernetes. It also makes release management very, very easy. So
Oh,
yeah, it brought in most of the features that are needed for the microservices architecture. Uh, and it was a language neutral kind of a thing, right? So it does not matter what the microservice is built in. As long as you have a Docker image or a OCI compatible image, you can run it in your Kubernetes cluster.
absolutely. Coming back to the slide, there's a lot of kind of information on this slide, and for a new learner, Ranga, this is really overwhelming. Just to help simplify, if it's a Spring Cloud, if we use Spring Cloud for Java-based microservice development, so everything that is there, like Eureka, Zipkin, Zool, so does it come like already inbuilt in Spring Cloud, or like do we have to set these things up individually, or we can just plug these components in individually in Spring Cloud and then Spring Cloud will manage everything for us? How does that work?
Yeah. So learning microservices can be a big challenge, right? So, I mean, there are so many things that we are talking about in here: Spring Cloud, Docker, Kubernetes, Spring Boot. So I think the first place where I would recommend developers to start with is get good at building REST API. Understand the fundamentals of REST, understand the best practices of REST, understand how to build web services, REST web services, and focus on that. Spring Boot is a very, very good framework. If you are a Java developer, probably I think the best place to start with is Spring Boot. Once you understand Spring Boot and you know how to build simple REST API or simple microservices, then you can get into the ambit of Spring Cloud. Then you can actually try and play around with each of these. Each of these are independent components. If you look at Spring Cloud Config Server, Eureka, Load Balancer, or things like Spring Cloud Gateway, Resilience for J, these are all independent components. You can choose to use one of these and not choose to use any of the others. So you have the chance of plug and play. You can add in specific components and add that specific feature to your microservice. So if you're getting started, probably I would recommend you to get started with building a couple of simple REST API. Let's call them Microservice 1 and Microservice 2, and see how you can bring in some of these features. So that's what I would start with. One of the like with the evolution of containers and container orchestration, I would say the some of the components in Spring Cloud become irrelevant soon. So I would say probably if you are actually like having a Microservice 1, Microservice 2, and you are building container images for them, so you learn how Docker works. Like once you learn Spring Boot, probably you can also learn Docker. If you learn Docker, you will understand how to build a container image for these microservices. And instead of learning Spring Cloud, what they can directly jump into is Kubernetes. So another journey which is possible is learn Spring Boot, build APIs, learn Docker, and then start playing with Kubernetes. Try and deploy these microservices to Kubernetes directly and try and play around with them and like try and see what features that Kubernetes provides you with. But important thing is to focus on one at a time. So these two journeys are possible. You can start with Spring Boot, build a REST API, go to Spring Cloud, or you can actually start with like you can start with Spring Boot, directly jump into Docker, and directly jump into Kubernetes world. I would recommend the second journey for now. I would say start with like building REST API, learn how to containerize it, and then try and deploy multiple microservices to Kubernetes and see like some of the features that Kubernetes provides.
Perfect, perfect. So now we have already kind of hit upon Docker and hit upon Kubernetes. Now without cloud, I think they are like half kind of standing on its own. So
Right.
once a developer kind of starts developing microservices, how important is understanding of cloud required for developing microservices in your view?
Absolutely. Yeah, I think when somebody is starting off the journey of learning the REST API, containerizing them, I think, and putting them to Kubernetes, I think that's where somebody should focus on. Cloud is something like when you are actually probably when you want to run Kubernetes, right? So when you want to run Kubernetes, you can either run it on your local machine or you can go to cloud and run it, right? So you can probably use one of the Kubernetes services which is provided in the cloud. And to use a Kubernetes service in the cloud, you don't need to know a lot about the cloud. So I would say if somebody is getting started with microservices, I would recommend them to focus on the basics: REST API, microservice fundamentals, understanding Kubernetes. Probably make use of the distribution of Kubernetes on the cloud, but you don't really need to know what is happening around the Kubernetes thing at the start. But once they complete the entire journey to microservices, I would recommend them to start the complete cloud journey, right? So learning cloud today is a very, very important skill. As I keep saying, cloud is a secondary skill. Being able to understand your language, the frameworks you use to build your microservices, the concepts around microservices, those are the primary skills. The cloud is the secondary skill. So learn the cloud, but it's only after you have primary knowledge on how to build microservices, how to use them. Unless you are in an enterprise where you are not really making use of microservices, like let's say you are focused on just building REST API. In that kind of scenario, probably you can directly start with taking the REST API, understanding the cloud, and how you deploy the REST API to the cloud. But if you're using a microservices architecture, the focus should be on understanding the microservices architecture, and then you can go to the cloud and see what features cloud provides to make microservices easier.
That's good. So in terms of like top three features that we should focus on, any kind of clues that you want to share with the learners in terms of cloud, other than Kubernetes, we know that.
Yeah. So if you're getting to the cloud, I think yeah, one of the fundamental differences between enterprise data center and the cloud, I would say, is the security aspect. Right? When it's in a enterprise data center, probably security is not as much as a concern for developers. But once we move towards the cloud, everybody in the cloud, I mean, it becomes kind of a cross-cutting concern. Earlier, security was kind of something which the operations team takes care of. I mean, if there is any application security, we worry about it, but things like network security or like physical security of the data center, like typically that does not become a concern for the development team. But once we move to the cloud, everything like because it's in the cloud, it's shared infrastructure. A developer needs to understand a lot more about security and networking than we would typically focus on. And
Very
the other thing I would recommend them to do is to try building the application which they are working on and try deploying it to the cloud. There are, like, if you look at compute options, right? If I'm trying to look at application, I would want to deploy it to deploy it in some way to the cloud. There are multiple options that are present in the cloud, right? So you have the infrastructure as service options. You can create a virtual machine and then you can directly deploy the application just like you do in the data center. Or you have the platform as a service options. You have a number of managed services which are provided where you just say, okay, this is the deployable unit I would want to deploy, and the cloud platform would take care of actually doing the entire deployment, creating the server, putting the software there, and finally you have a URL you can use, right? So I would recommend it to explore like those options in addition to the serverless architecture, right? So serverless architecture is something which cloud enables. So that's probably the third thing which people can try and explore a little bit more when they are going to the cloud.
awesome, awesome. So these are all the options. Now, what are the prerequisites in terms of like bare minimum one should learn in order to develop basic microservices? Is this just like Java or Java plus plus?
Yeah, I think somebody being good at their programming language of choice is very, very
Yes.
important. So you have to be an excellent Java programmer, or if you're building Python microservices, you have to be an excellent Python programmer. So programming and being able to build good REST API in your language, right? In Java,
Okay.
it's Spring Boot, which is used to build REST API. In Python, it might be Django or things like that. So whichever framework is used in your language to build REST API, you should be good at it. You should be good at the REST API fundamentals. I think that's the fundamentals, and then you can add on the microservices related skills on top of it, right? So you can try and build containers. You can try and understand container orchestration. So I think the prerequisites are being good at building a REST API, and you can
Yes.
slowly add in other skills as you go on.
Okay. Okay. So have one understanding, like solid understanding of one programming language, and using that programming language, building REST APIs, right? And once you are
Absolutely.
through with this, and then you can kind of evaluate how you can deploy those microservices in cloud kind of environments, and then advanced concepts of Docker and Kubernetes. That's the way
Exactly.
to
I
go.
mean, yeah, I mean, as we see, right, there are a lot of things to learn, but the important thing is to focus on one thing at a time. You cannot go through the entire journey very quickly. I mean, then you get confused. It's very important to understand, like, start with programming. If you have no knowledge of programming, start with programming, understand it, spend a few months with it. Programming is the toughest thing to learn. Building a REST API might not be as tough as learning programming. Maybe you can do that in probably a month. If you're a good programmer, if you're a good Java programmer, I think you can learn how to build REST API with Spring Boot in, let's say, 2 to 4 weeks. I'm talking about the basics, right? I mean,
Yeah,
I'm not talking about understanding the design and the architecture and all that stuff. At a high
absolutely.
level, being good at building REST API, you can do that in a month, right? And like the tools aspect, containers, container orchestration, I think both of them people can learn within a month as well. So the biggest challenge for me is the programming concepts part of it, which takes time, right? If you want to be good at a programming language, that takes 3 to 6 months, and if you want to master a programming language, it might even take 10 years, right? So it's that part is difficult, but the frameworks and tools part of it is the easier part. A lot of people actually have the misconception that the tools part is difficult and the frameworks part is difficult. But in my view, having taught a lot of people microservices, I feel the framework part and the tools part are the easier things. The concepts of microservices are easier to learn than concepts of programming.
Right, right. So this is for someone who wants to get started without any programming knowledge. So for example, if I am already a kind of 3 years experience kind of a programmer in say Java or Python, right? I have good understanding of the basic programming concepts, right? The functions, methods, inheritance, and
Right.
whatnot. And I've been working on kind of support maintenance kind of project where we are still in a legacy monolith basically architecture where we have MVC or just JSP servlets. And now my next project is into microservices. So how can I start? Because I have a good understanding of Java. So should I kind
Mhm.
of just start with understanding architecturally what is a microservice or and REST, and then go hands-on lab, or should I start with Spring and then Spring Boot? Like what's the steps there?
Yeah, I think the first thing that you need to understand is what is the technology that is being used in the microservices architecture of your project. Right? You need
Right.
to find out, okay, what's the architecture? Are they making use of Spring Boot, Spring Cloud? Are they making use of Docker, Kubernetes? So you need to find out what are the important things that are being used, right? So you'd want to learn the same thing that is used in the specific project. So I would start with doing a little bit of research and trying to find out, okay, what's the architecture that is in place, and then I would start with focusing on whatever helps you build the REST API, right? So if you would want to like if you they let's say they're using Spring Boot framework to build the REST API, I'll try and focus on Spring Boot. Let's say if they're using containers, container orchestration, after that I would learn containers and container orchestration. So the steps are the same, right? REST API, containers, container orchestration. And after that is whatever, right? So these
Right.
three things would be common, irrespective of what technology is being used. I would say today, probably most of the microservice architectures use some kind of container orchestration solution. So the REST API container orchestration is the flow I would recommend.
Awesome. I think we have discussed a lot of things around in today's session. Like we've given information about microservices, RESTful microservices, what are the challenges, advantages of microservice architecture, and what are various technologies that we can use, like Spring Boot, Spring Cloud, Docker, and Kubernetes. I think this session will be very valuable for a new learner who wants to enter microservices. I think thank you very much, Ranga, for sharing your thoughts and deep insights.
Thanks a lot, Amit, for taking the time to be part of this discussion.
My pleasure.